Hi everyone, good afternoon. I am Harshit Agrawal, a computer science student currently diving deep into machine learning and NLP. I am thrilled to share my latest project where I fine-tuned a transformer model to perform sentiment analysis on YouTube comments. I would like to sincerely thank CV Raman University and my mentor from Cranes Varsity, Mr. Partha Chatterjee, for guiding me throughout this journey. This project focuses on automatically detecting the sentiment of YouTube comments, whether they are positive, negative, or neutral. I used a label dataset containing user comments and their sentiments. The core idea was to fine-tune a pre-trained distilbert transformer model using the Hugging Face Transformers library. So here we are installing the datasets. As you can see, it is downloaded, and we are importing the necessary libraries. I started by encoding the labels mapping positive, neutral, and negative to 2, 1, and 0 respectively. I split the dataset stratified sampling to handle class imbalance. Using Hugging Face auto tokenizer, I tokenized the data and trained the distilbert-base-uncased model for sequence classification. The model was fine-tuned with appropriate training arguments, and performance was evaluated using accuracy and F1 score matrices. After training, I tested the model using Hugging Face pipeline interface. Here are some results on new comments. This is an amazing tutorial predicted positive. When I entered, I am confused by this explanation. It predicted negative. It's okay, neither good nor bad. It predicted neutral. So it was working uh, with promising accuracy and weighted F1 score. This project gave me hands-on experience with transformer models and practical NLP. Once again, a huge thanks to CV Raman University and Mr. Partha from Cranes Varsity for their incredible mentorship. As per regarding the future scope of this project, uh, this model can be enhanced by integrating it into a real-time YouTube comment moderation system, expanding the dataset with multilingual comments to support diverse user bases, using larger language models like BERT or RoBERTa for improved accuracy, building a dashboard or web app to visualize sentiment trends for content creators. So let's go through the codes. First of all, we have installed datasets using pip command. Then we have imported the necessary libraries, which are pandas, sklearn, model selection, brain test split. Of course, we will need that for training our model. And then we have imported datasets, dataset dictionary. Then from transformers, we have imported the auto tokenizer, training arguments, trainer. Then we use auto model for sequence classification as sequence mod CLF, which is an alias for this. Then we have used torch, numpy, and from sklearn dot matrices, we have used accuracy score, F1 score. Then we have uh, uploaded the files from our system. Then we have uh, uh, in the CSV format, we have read the dataset using pandas library. Then we have gone through the dataset info using info function. Then we have counted total number of rows which contains null or which does not contain any values. Then we have dropped those columns. After that, we have encoded labels, as I have told earlier, negative S0, neutral S1, positive S2. Then we have encoded dataset. Then we have renamed from comment to text, sentiment to label. After that, we have trained. We have used 70% dataset for training and 30% for testing. Then we have trained, test. Then after all, you can see that we have tokenized the dataset with an auto tokenizer from pre-trained. These are tokenized datasets, which is printed. So now we have trained your epochs. You can change the parameters here for epoch and train batch size, eval batch size for more accuracy. I have decreased the parameters so that the epoch loading time can be reduced. Then we have computed the matrices, accuracy score, Afoni score, trainer. At last, we have saved the model. As you can see, these are our testing comments. This is an amazing tutorial which gave the output true, 1, which is positive, and same for the others. So that's all. Thank you very much.